One of the important calculations is Phonon calculation. If you are not familiar with Phonon calculation, this below paper is appropriate for you. I recommend it. To do Phonon calculation, we do 4 steps. The first step is self-consistent field calculation. We did it before. In the second step, we should calculate the dynamical matrices on Q vectors. To do this, we create a folder with Phonon name and then we copy the contents of the self-consistent field folder in it. We use PWGUI graphical interface to create an input file for Phonon. We choose File, New, and then ph.x. We specify the title, Phonon. We specify the direction of the Phonon folder here. We specify the prefix name that should be similar to prefix in self-consistent field calculation. Then we specify the file name that contains the dynamic matrix. I choose gr.dyn. In the what to compute section, we enable phonon dispersion calculation by clicking on yes. In the control option, we specify the number of atoms type that in graphene case is 1 because all of our atoms are carbon and the atom's mass is 12.0105. We enter this value here. Also, we define the threshold value for self-consistently. You can see its default value. Its default value is 10 to the power of minus 12. I enter the same number. In the Q and K point section, I specify these 3 parameters, 6, 6, and 1, NQ1, NQ2, and NQ3. Then we save the file in the Phonon folder with this name gr.ph.in. We can see our input file here. We should run this file by ph.x. To run this input file, I go to terminal environment and we write mpi run ph.x, the name of input file, that is gr.ph.in, and the name of output file. We can see that some new files are created in this folder. After some minutes, the run is over and you can see some new files are created here. At third step, according to this formula, we should calculate interatomic force constants, IFCs, in real space. It is a Fourier transform to real space and obtain force constants by interpolation. To do this, we should create an input text file, assign input. I should define the file contains dynamic matrices. Its name is gr.dyn. I specified it before. Another parameter is ZASR, that it should be simple. And then we should define the output files of interatomic force constants in FLFRC. We choose gr.fc for its name. This file containing the interatomic force constant and a list of Q points for which the frequencies are to be calculated. After that, we should save it in the Phonon folder with this name. gr.q2r.in. I save it. We can see this created file here. We should run this file in terminal environment. The name of input file and the name of output file. You can see this output file is created. And the second step is done. In the fourth step, we should calculate all phonons from the dynamical matrix given the force constant. To do this, we create an input file. In the input file, we define the ASR to be simple. This indicates the type of acoustic sum rules. We define the atomic mass to be 12.01. We specify the file that contains the interatomic force constant that created in the previous step, I mean step 3. It was gr.fc. Also, we define this file. This is the file where Math Dynamic writes the interpolated frequencies, and after that, we should define routes for K points. We created such input file in the Phonon folder. As you can see, this is the input file. Now I should run it. mpi run math dyn.x. I should name the input file gr.mathDyn.in, and then after the run is over, we can see this file gr.frequency. We should plot this file. To plot this file, we write in the terminal environment plotbond.x command. My input file is gr.frequency. Its range 0 and this. My output file, I specify its name and the PS file. The Fermi level energy is 0. Delta E, I assume that it is 0.2. And the reference energy is 0. we can see that this file gr underline frequency dot plot is created, and also there is a ps file. We can see phonon dispersion easily. Also we can plot this file gr underline frequency dot plot. To plot this we can use gnu plot and then type plot the name of this file, that is gr the line frequency dot plot with lines. We can see that phonon dispersion figure is created here.